Welcome to Lesson 14. In this lesson, we're going to build on your knowledge of loops to do simple aggregation of information. That's a very fancy word of just, kind of doing stuff, collecting information, and doing something with it. In conjunction with that concept, we're also going to introduce another one called accumulators. Again, another fancy word to simply mean that we're going to increase a variable or modify a variable in some way mathematically. So let's get to it. So let's say we have a variable s, and we set it equal to 0. And let's say we want to increase s by 5. Not set it equal to 5, increase it by 5. So what I'm going to write is I'm going to write a plus equals. This is a shorthand operator, which we like to call as an accumulator. This will increase s by 5. And let's just prove it to you. So let's print it out. All right, so you can see here we got 5. Now I'm going to copy and paste this code. And I'm curious to see what you think is going to print out in line 5. Some students might think, well, it's just going to print out 5 again because there's a 5 here. But remember, this symbol here, this plus equal, this shorthand operator, means that you're going to increase s by 5. So if we increase s by 5 here, and then we increase it by 5 more, we should have 10. Right? So this plus equal we call an accumulator. It increases the value of a variable by whatever you put here. So we could take this a step further in that now that you've learned how to do for loops, we can stick those two statements in a for loop. And let's simply have it run 10 times. With each time us increasing the value of s by 5. So take a second, think about what's going to print out. All right. Hopefully your guess was correct in that because we're increasing it by every 5, that means we're going to print out 15, 20, 25, all the way to 50. Because each time the value of s is increasing. It's not getting set to 5, it's increasing by 5. Now the other thing we can do too, it doesn't have to be just addition. It can be subtraction. So think about it. If you start at 0 and each time subtract by 5, what's going to print out? Okay, so similar idea, except that now they're in the negative side. And obviously, at this point, we could do all kinds of things where, you can multiply by 2. You get a whole other set of ranges. So this simply modifies the variable. Once the variable is modified, you could do whatever else you want with it. This is called an accumulator. Let me give you another example. So we're going to erase this. We're going to stick with the idea of the s. But now, if you recall, the value of I, and let's just do this, just as a review. The value of I is this, 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9. So what if we wanted to actually add up these numbers? So we could do this. We can do s plus equals I. Again, and what are we adding? We're going to add the 0, then the 1, then the 2, then the 3, then the 4. So what's going to print out, well, this is just going to print out the numbers 0 to 9. But let's say we print out the sum, the s afterwards. So the sum of all the numbers from 0 to 9 is 45. And again, if we wanted to actually include the 10, we would just go up one more. All right. So this is also a very common thing to do, where you would take the value, the loop variable, and include it as part of your aggregation of information. And then we could do other things with this. Maybe we want to do I times 3. And at this point, I'm also going to print out the value of S as it's being built. So you can kind of see how it's changing. And you know what? While we're here, I'm going to print out the value of I as well. So you can see here, nothing special, 0 to 10. That's the value of I. That's the first value that gets printed out. But then the next number is the value of S. Now notice it's not just I times 3. It's the summation of the previous value of I times 3. Again, this example is a little bit hard to understand, but if you could work through it. So 0 plus this, 0 times 3 gives us the 3. This times 3 gives us 6. 6 plus 3 is 9. Again, this is a very difficult example to follow through, but just to show you, you can do a lot of things with your loop variable and accumulating the information. Now, the other thing you can do too is, doesn't necessarily have to be the loop variable. Here's another example. So let's say we decide to ask the user for some information. So we'll say n is equal to int input enter number. Okay. So now we could do sum plus equals n. And what we end up doing is we end up adding up the numbers they entered in. Now I'm going to keep this small. I'm going to do it to 3. And let's see what happens. So enter a number, let's say 5. Let's say 4. So now we should have 9. And let's say 1. Sum is 10. Okay. And again, if we run the program again, we can enter another set of numbers. Let's say 2, 2, and 2. 6. So what you're seeing here is that there's different ways of collecting information. You could do it from just a straight number. You could do it from the loop variable. You could do it from input. I'm not going to demonstrate it here, but you could also do it from a random number. Again, you could aggregate any type of information. And also, the aggregation doesn't necessarily have to be addition. It could be subtraction. It could be division, it could be multiplication, anything's possible. All right, so again, just read the problem and you'll be able to aggregate information. So let's go back to our presentation. So having learned loops, one of the strengths of loops is that it could repeat a process very rapidly. And sometimes a process just needs to collect information, find some calculation to a set of numbers. And that's where an accumulator, the plus equals, minus equals, multiplication equals, division equal operators come into play. And then the aggregation is just using that same concept to accumulate it to a variable. So I'm looking forward to see what you do with the activity. Enjoy.